Hello, my name is SpeedTorch Gupta, and I'm going to give you an overview of how to use SpeedTorch. In this case, we're going to be using it for Word2Vec. So this is our Word2Vec architecture. It has two model embedding variables, and it has a forward pass. And when we instantiate this architecture, we want to set the number of embeddings equal to the batch size instead of the total number of classes. And since the model variables only have a batch size worth of embeddings, we can set sparse equal to false since during the update steps, all the embeddings are going to be updated. And since sparse is equal to false, we can use optimizers that are not normally supported for embedding training, like Adamax. And we install SpeedTorch. Before we import SpeedTorch, we want to import CuPy because SpeedTorch uses CuPy. And now we want to instantiate our embedding switchers using the SpeedTorch model factory. So we pass in the model variables, the total number of classes that we're using, and the embedding dimensions. And then we want to initialize all of our embeddings using uniform and normal distribution. And then we also want to instantiate our model switchers, our optimizer switchers for each of the variables using the optimizer factory. So we pass in the optimizer, the total number of classes, the embedding dimensions, the instance of the model architecture itself, and the name of the variables as defined in the architecture code. And for the optimizer switchers, I want to host them on the CPU. So I set the CPU pin equal to true. We initialize the optimizer switchers. And so to reiterate, the switchers, they contain the entire set of embeddings. The model variable itself and the optimizer itself, they contain only a batch size worth of embeddings. It's the switchers that contain the full set. And so during this is our training loop, and during each training step, we generate a batch of indexes that correspond to the embeddings that we want to train for that step. And so we pass in these indexes to the before forward pass method of our switchers. And what this method is doing is it's taking the index and getting the specific embeddings belonging to that index and inserting them into the model variable set of model variable embeddings. And it's also doing the same for the optimizer switcher and the optimizer itself. So now the model variables and the optimizer weights, they contain the corresponding embedding weights as specified by the batch generator. And so now they go through a forward step loss calculation and gradient calculation and update step. And now the after optimizer method, they take the updated weights and they pass them back into the total set of weights. So this after optimizer step, they take the updated weights from the model variable and the optimizer, and they put them back into the total set. So now the total set has an updated version of the weights. Okay, that's it for now. I wanted to make a short video, so thank you for watching.